Hello and welcome from Emerald Hill Skies. Cloudy Emerald Hill Skies tonight, but we have faith those clouds are going to clear. Thanks to all those who are already online waiting for the startup of this, our second try at a Messier Marathon here in the spring of 2024. So thanks to you faithful that are watching live. And if you're watching this as recording, thanks to you as well. We do have faith that things are going to clear, so if you are interested in the observatory or the equipment, maybe some maybe canned pictures of some of the objects that are going to pass us by here very shortly, then feel free to scrub forward in the timeline at the bottom until you see the telescope being live on some objects here. Otherwise, we'll at least go ahead and get started. I'm here for the evening. I have faith things will clear off. It's just that we'll miss some of these front-end objects. So let's go ahead and get to the sky. This is what we have right now looking toward the west, which is where we want to go in order to find Messier 74, M74. It's sometimes called the Phantom and otherwise known as NGC 628. So somewhere behind all those clouds, that's where M74 would be. You can see they are moving along toward the east. So we have faith that they're all going to clear off here in a while. But the app, Clear Outside, had predicted that they would be pretty clear by now. This particular object, M74, is a galaxy, a spiral galaxy in the constellation Pisces. And it's down to about 14 degrees. Now let's see if we can come to our screen so you can see Stellarium, our planetarium software. This line here that you see with a red line, that pretty much corresponds to what we would guess is a very conservative view of our tree line over there in the west. You can see the Phantom Galaxy, M74, is right here. And at least if we can't see it live, we can look at a nice piece of artwork here of it. You can see it has well-formed rings and a lot of star-forming regions. All these bluish tint areas are regions of star formation. A real bright core. It lies about 30 million light years away, and for it to be 30 million light years away and still show up nice like this, pretty much magnitude 10 object, 9.8 or 10 object. It is over there in the western sky for us here in Louisville, and that western sky, as you can see, is kind of a light polluted area. We are located in the southeast outskirts of Louisville, Kentucky. So there is a lot of light pollution over there, and the cloud bank especially picks them up and just exaggerates them all the more. But our view would of course be a little bit less enticing of this object. It sets around 9:19 at the latest in our western horizon. So to get an idea of what that looks like, let's back off and take a look now. This next level, this is a constellation line. So that's just one of the lines that you would see there in a constellation. But by the way, Pons Brooks, the comet, is right here off to the right of M74, and I had hoped if we could get an early view of M74, we could sneak over and see the comet Pons Brooks. The tail is formed up nicely now. But so far instead, this is what we're seeing. Let's go to a live view of our real-time camera. Now brace your eyes. You might want to narrow your eyes a little bit. Why don't I darken this before I show it to you? I'll go down to maybe 1 second exposures and maybe do around 200 gain. That's a little bit too dark. Try 300 gain. 350. Okay, so that's probably a little bit going to hurt your eyes a little bit less. Okay, here we go to the screen camera. So this is the real-time view through the ZWO ASI 2600 MC Pro Astro Color camera, the Astro-specific camera on the end of the RASA 11. That camera looks like this. It's the red circular piece of machinery there on the end of the glass of the plate, the corrector plate on the end of the RASA 11. You can see it's mounted to an Octopi Astro camera adapter there, and then to the glass of the Celestron RASA 11-inch aperture scope. That 2600 is seeing pretty much just this right now. So one of the things we would want to do if we could see stars right now would be focus. And then the second thing we'd want to do is plate solve, in other words, match the sky with our view through the telescope. We could do that probably with a fairly small section of the sky, even if a 2-degree window opened up, just a 2-degree patch in the clouds, we would be able to plate solve and be able to focus. But as you can see there, those clouds are not cooperating at all. So I'm afraid we're going to miss out on our first object. We're just 1 minute from its setting into the trees. So let's go to the second object, and it is M77. And that'll at least keep our scope from, well, before we leave the Phantom M74, let me just tell you that this was discovered by Pierre Méchain, who is Charles Messier's assistant, in 1780. And it does have a very low surface brightness. In fact, some people say it's the most difficult object to capture. But man, it has 100 billion stars. It's a beautiful, beautiful galaxy. And it is the source of a lot of X-ray signal. If we could just have an X-ray scope tonight, it actually radiates more X-ray power than a neutron star. And the cycle of X-rays strengthen every 2 hours. So it must be a slowly turning kind of source. Has a mass of maybe a billion suns or more. So it's really super powerful. In the middle would be a fairly good sized black hole, maybe intermediate size. And that's probably small for this kind of galaxy, but that's what it appears to be. Most of the time they would be one of those supermassive black holes. So again, you're looking at the piece of the cloudy sky where M74 would be if it were not so clouded up right now. We are not going to be able to see M74, so let's go on to M77. So now we're going to salute M77, and again, we'll just look at the skies. You can see the camera spin a little bit there as we slide over at M77. Let's go to the planetarium software and take a look at M77. Now, at this point, I get to also show off a really cool control panel that Pete has been working on for us. Pete is observing live with us from the Isle of Wight. It's just off of southern coast of UK, southern coast of England over there, and he's sipping tea. He's over there live with us, listening to some soft jazz music. And Pete's been working on this control panel for us. I'm really a fan of things meshing together well, and thankfully Pete is as well. And what he's done is he's married together the 3 main software applications that we use in our form of EAA. On a clear night, on a cloudy night, it loses some of its punch, doesn't it? The 3 main pieces of software are SharpCap, which is this observing software that's letting us see all these clouds close up, about a 2-degree slice of clouds there, and Stellarium, which is this planetarium software, and AstroPlanner that you see over here to the right. See, that would be right here. That little thin white stripe of a program up and down this little strip of the screen, that's our targeting software. And what Pete has done with this, what he's calling EAA-CP, it's electronically assisted astronomy control panel. He's basically said, click this button if you want to do a quick observation in AstroPlanner. Click this button if you want to sync automatically with Stellarium. So we're going to put our cursor on M77 and hit Stellarium sync.
Select it.
And that's how fast it is. It's a pretty much of an instant control panel to marry these three software applications together. So let's back off just a little bit and again see where we are. We're just a little bit now south of west. So if you were here on our property, you would see we're looking right over the top of this little, we call it a prayer shelter, but it's a gazebo. Right over the top here in the western sky, just south of west. And you can see in due west now would be Jupiter and Uranus. And here's that comet you've been hearing about, 12P Pons Brooks, 2024. And we were just here in this area with M74, looking at the clouds in front of it. And now let's zoom in on M77. So you can see M77 is also a galaxy, but has a little bit less defined arm structure, doesn't it? It kind of almost begins to look a little bit ellipsoidal, but it is supposed to be a barred spiral, and this is in the constellation Cetus. It's about 47 million or so light years away. In fact, some researchers have plotted it to 46.97. I don't know how you get that close to something you can't hold a yardstick up to. It was discovered by Pierre Messier, again, Charles Messier's chief assistant, only assistant, 1780. And he originally described this as a nebula, which meant all he saw was a cloud. And you can understand why he would say that with the artwork we have here in the planetarium software. Both Messier and Herschel described it as a star cluster. And you can see how Messier would have thought that with his little 3.5 or 4 inch refractor. I learned in getting ready for this night that his refractor was actually pretty much a complicated one. It's what you call that apochromatic that's supposed to make some corrections for some of those color problems that the original refractors had. But it is a bright and fairly close example of a type 2 Seyfert galaxy. And in a way, astronomers use this as sort of the poster child of Seyfert 2 galaxies. And again, at its core, there's a nice bright X-ray source, and it has one of those radio jets coming out of it. Not the one that we're familiar with looking at. What is that, Messier 87 that we can actually see with the Rasa 11? But this one is a radio jet. If we could use the equivalent of a Rasa 11 only for X-rays, we'd be able to see that radio jet coming out just like we see the relativistic jet coming out of whatever that is, M87 or whatever. And it interacts with the interstellar medium in such a way that it's sort of warped these arms. That's the hypothesis anyway. There's also a cloud of cosmic dust that is here. And by the way, that cosmic dust keeps us from seeing the core very well. Actually, there's a supermassive black hole in the middle of this. And there's this really cool experiment I read about for this, Messier 77, that's happening down in the Antarctic. They've taken a square kilometer of ice and they've buried lots and lots of little radio receivers. And they're like just 1 meter apart or something, just a whole network of radio receivers. And so they work like a giant square kilometer wide, I guess you could say like a radio telescope that's a kilometer wide. And the experiment is called the Ice Cube, and there's some acronym that I guess stands for, but it's fitting that it's down in Antarctic. And it has now detected a neutrino source from the middle of this nucleus of Messier 77. And that Ice Cube experiment should be able to detect these neutrinos now all around the universe. So that's pretty exciting. Let's go back to our sky cam. Take a look at those beautiful thick clouds. Notice what a great job our ZWO ASI 178 monochrome camera does of those clouds. It's just exquisite that you can pay. What is that camera? Is that a $300 camera? It's really amazing. You can pay $300 to get this nice of a view of those boiling clouds, huh? So M77 sets right about now. So let's go back to the planetarium software and back off a little. So now Stellarium does not show its setting yet, but I guess depending on my tree line, you know, depends on where you want to place your trust. The line drawing that you see here in Stellarium was done with the RASA. And what I basically did is kept turning the RASA like as if it were a alt-azimuth scope, and I would take another reading and turn it a little more and do another reading, and I just kept shooting it as best I could, and that's what the red line is from. But this photorealistic horizon is just a camera image of the property here, and there you can see like the edge of the observatory. So this would be like kind of like this, like instead of bird's eye view, this is the scope's eye view, and I even have it elevated at the same height as the RASA on top of that adjustable height pier that PureTech provided for this scope. It actually raises up from within the observatory once you roll off the roof and elevates the scope up above, just above the edge of the observatory. And so that view that you get here is supposed to simulate the view of the scope. I guess no matter how you slice it, that object is getting close to the tree line there, isn't it? But actually, AstroPlanner shows it at 13 degrees now, and I think this looks a little high to me. Let's see. Let's go up here. Nope, 13 degrees is what Stellarium is showing, so maybe my tree line isn't as high there as what I have it. Let me catch back up with you guys on the live stream. Kind of been catching these first two objects because I was kind of in Messier Marathon mode. Grab those first two, you know. Well, there's Vito. Back a couple of screens, you see PureTech checking in. He does that occasionally. So Vito, I hope you're still on, but you're seeing your handiwork here. Not only the PureTech adjustable height pier, but also the Telestation 2 observatory. That was all handmade by Vito in his shop at PureTech. So once again, we've got to say thanks to you, Vito, because amazingly, this observatory is still, I haven't seen the first varmint in here, and this thing is what? Is it coming up on 2 years old, and knock on wood or whatever that is, we've not had one varmint. In fact, there's not a single dead fly on the floor in there. It's just been completely impervious to insects. And I heard back when Cloudy Nights used to let me view their stuff, now they've kind of thrown me off because they thought I was a vendor and thought I wasn't playing by the rules, I guess. Although I'm not a vendor and I tried to play by the rules. So I no longer can get on Cloudy Nights. But back when I was on Cloudy Nights, all those guys would tell me all kinds of funny stories about mice and, you know, squirrels and everything you can imagine. But we have yet to see one single first mouse in this observatory. But you can see I keep the floor pretty much, there's nothing there for a mouse to get into. So I think that's part of it. I don't go out there and snack. There's no food on the floor. But even in the warm weather, I mean, even in the cold weather when they might want to come in to get out of the cold, I've yet to see a single squirrel or any kind of varmint, praise God. In fact, I don't even see spiders in there. Honest as God is my witness. There are no spiders in there so far. And you would see them because there's no place for a nest. So this observatory has been great. Vito, thanks a lot. Tiffany, good to have you aboard. Let's see, let me catch up. Ricky from Florida, good to have you there. Yeah, Larry's saying it doesn't look promising. But see, Larry, you just have to believe. So I know you do, Larry. No storms, but lots of clouds. Walter, good to have you aboard. Stu, went on a school trip to the Carter Observatory in New Zealand to see Halley's Comet. Was a pivotal point in my life. You guys are remembering some of those great memories. Let's see, catching back up. Still really thick clouds, right, Gerard? Miles Davis, you guys are doing all kinds of things to pass the time there, aren't you? Yeah, Larry, it's just, to me, it's just a blessing to have that pier. Larry's saying he would love to have one of these as well. Boy, we're so grateful. When you lower it, I worked a lot with Vito to try to imagine what height this should be, and Vito got it spot on. I mean, we were within 8 inches. So what I did, I don't know if you can see in the drawing, but I actually used a little 8-inch pier extension. If you look right above the door opening, there's a black column on top of the adjustable height pier. That's an 8-inch pier extension, and that gets it to perfection. Now when you lower the scope and put the scope level, so in other words, equal to the ground in its orientation, the roof just clears it. So that we were within 8 inches, and of course, Vito was right to be conservative. You would want to be 8 inches on the conservative side rather than sticking out into the roof 8 inches. Stu is saying the more that we click the like button, the more likely the clouds are to clear. Now that's something I hadn't heard before, Stu. Thanks for that. Yes, it is one of their observatories. And boy, for my part, Larry, it has really been worth it. I could have done this in plywood, I'm sure. But of course, then you have to wrestle with ground movement out there where those columns are eventually. And just the reshifting of the sands and the wood. Stu says that a bear den would make a great bear den. I'm sure you're right. Cloudy nights. You're right, Jared. It is funny the way they threw me off. They thought I was a vendor, and anyway, they just got tired of me. And you know, I've done just fine. Pete referred me to another site that I've got to say has been a real blessing to me, and now I frequent that site instead, and it's called Sky Searchers. I thought I had a link. Here it is. It's my second link, the Sky Searchers, and I love it. This is the EAA page, and they're so nice and civil, and nobody's accused me of any ill will or hidden agenda or being a vendor, or I don't even think they care. It's been so much more laid back, and I can ask a question and not get any guff. So I'm loving Sky Searchers, and it's just theskysearchers.com. So anyway, hope you'll, oops, I need to put that on the screen. theskysearchers.com. All right, so I think that catches us up. Walter, good to have you. Just observe Pons Brooks binoculars. You are so lucky to have clear skies. Magnitude 6, very small core. Dave says he wants to build a roll-off roof this summer. That'd be awesome. All right, let's get back to it here, gang. So that pretty much, let's go back and look one more time at those broiling, roiling clouds. But they're going to clear, I know they are. All right, the third object that we want to look at to see the clouds in front of it is M33. And again, we'll just select Stellarium, and that's how fast it is. So again, you can see we're still in the western sky. Now we're a little bit north of west, so right over the light dome here. Right over the light dome. So here would be west. There's the roll-off roof of the observatory. So again, this is a scope's eye view, and you can see if we were able to see through the clouds, this would be what we'd see. It's a beautiful, called the Triangulum Galaxy, M33. Some people call it the pinwheel. You can see, for obvious reasons, why they do that. Otherwise known as NGC 598. It's a spiral galaxy about 2.73 million light years from Earth, and it's the third largest member of our local group, behind the Andromeda is number 1, and then Milky Way. So it would be the smallest spiral, and it is called the Triangulum Galaxy. But I noticed when I was preparing for this that Simbad, that site over in wherever it is, Vienna or whatever, from which we all rely on all of that, pertinent, precise information, including the designations, the designators of all these objects, they refer to M101 as Triangulum, which I think is odd, M101. So this one is Messier 33. And again, it's 2.73 million light years away. You can see a lot of star-forming regions in this spiral as well. Lots of new stars that we know now are coming to light. And look at this pinwheel structure. Isn't that beautiful? All those arms, so nice and neat, well organized. And again, this is the calculated horizon, supposedly, by using the RASA to sort of shoot the horizon one single position at a time. Basically, every 5 or sometimes every 3 degrees. So that should be our tree line. But then we put this photorealistic tree line underneath it. And that way you can see a little bit about what's going on. There's that Pons Brooks comment. If you want a real-time view of this, that's the real-time view. So this is from our monochrome camera that's mounted on top of the RASA 11. You can see that this monochrome camera is quite a bit smaller. It's the little red camera on that outrigger. On the left frame, you get a better picture of the way the outrigger is fastened to the top of the RASA 11. Then you see that little black lens in the right frame, the little black lens on the front. The only thing I don't like about the 178 is it is manually focused. So if and when it does get out of focus, we literally have to fire up the screen that's out there in the observatory. Can you see the screen? It's mounted on that far wall, and it just looks like a black flat screen on that far wall. And then there's a little fold-down keyboard shelf there. And so you can operate that, put your laptop on that keyboard shelf, and then operate from that flat screen and use that to focus the 178 as well as whatever other maintenance that we have to do out there. That's what we have to do. There's no way to focus the 178 from in here. First world problems, right? But you can see our focus is pretty fine of those clouds. So you're getting a very focused view of those. You know what I like? Look at these. Let me swivel over to that screen with you. Look at this patch here. Who knows what we could see through that patch? And look at this patch up here. So this gives us hope that we're starting to see some breakup of this cloud bank. That shine you see up there is a little bit of the reflection of that, what is it, a 69% moon? Is that what it is tonight? Yeah, 68.8% illuminated. There's a nice view of the moon through that clear patch. Like a bit of a beacon there for us saying, wait for me, Doug. Wait for me, Tiffany. I'm coming soon. Anyway, that's the Triangulum Galaxy that we would look at, and it's right now at 17 degrees. So we missed it. So we're going to miss 3 objects. Let me catch back up with you guys over here. Walter's observing from Arkansas with us, so that's why you've got clear skies. I think we just ought to pack everything up tonight. What do you think, guys? And head over to Arkansas. Stu, I know you would fly in. Oh, Stu says that it's called the Pinwheel Galaxy, after the lady who found it, Penelope Wheel. That's good, Stu. Gerard's talking about he observed Comet Holmes. Very bright face on back around late fall, early winter. Stu says, I'm not falling for that. This is why they don't let me edit Wikipedia. Aim for the holes, Doug, Stu says. I think that's a good idea. 32-inch Daub. That's a great idea, Gerard, but I'm not sure we could afford what we have, let alone that. Stu says we've booked Hubble, but there's a waiting list. Yep, minus 106 to go. All right, let's head to the next object, which was slated to be Andromeda Galaxy. So let's slew to the Andromeda Galaxy. At least, if we can't see anything else, we can at least watch the telescope move for kicks. It's pretty bad when you get your most excitement from watching the telescope slew. If you've joined us late and you're watching the recording of this, boy, are we sorry. You get all your money back. But anyway, that's our 11-inch Ross out there in the observatory live. And right now it's aimed at these clouds that are just right between us and Andromeda. Now if you look down at the bottom of that live view, you can see the observatory here. This is the roll-off roof of the observatory. And this little black shadow here is, let me turn off that title for a second. That black shadow right here is the dew screen barrier, whatever you call it. The dew, what is that? To keep the dew off the screen. That's what you're looking at there. And then this little thing here, it looks like an antenna, is for the Wi-Fi out in the region of the observatory. So it gets the Wi-Fi signal up out of that aluminum, PureTech aluminum shielded observatory, so that people who are in the vicinity of the observatory have a wash of Wi-Fi there. Anyway, there's the tree line, and Andromeda would be at 13 degrees, so right above those trees. So let's zoom in on a live view of those trees. This is the view that's 2 degrees, 10 minutes, and 29 seconds wide, 1 degree, 27 minutes, and 9 arc seconds high. That's the live picture of Andromeda with those clouds in front of it. But I think it's probably at this point a little more helpful to look at Andromeda using Stellarium.
Selected.
Okay, so you can see we're still in this basic westerly area. Now we're a little bit northwest. For alignment's sake, there's Pons Brooks, been, kind of right there with us all night so far in the Triangulum Galaxy. And you can see 3 targets here together that we would have looked at. The Andromeda Galaxy, which is M31, and then a companion to the Andromeda Galaxy, M32, and then a slightly more distant companion, M110. And you would have seen, here would have been our calculated horizon with using the observatory like you would use a what is that? Surveyor's, whatever that machine is called that a surveyor uses. You guys know that. What does a surveyor use? Sextant? No. Dew shield. That's right, Gerard. That's the right name. Dew shield. What is the machine that a surveyor uses? Anyway, using the RASA like a surveyor's instrument, and you would have seen we would have just caught it in time here. Now, Andromeda is the showpiece, of course, of the night sky. It's a barred spiral, and it's the nearest galaxy to the Milky Way. And of course, you guys know it was originally referred to as the Andromeda Nebula because it was so big, it just looked like an astronomical cloud. Yes, Stu, that's right, theodolite or total station. Perfect. Theodolite. So we use the RASA like a theodolite or a total station. Anyway, it was called the Andromeda Nebula, and it's about 152,000 light years, for perspective, from end to end. And that's not too different from the Milky Way, roughly the same. By the way, we will probably collide with this galaxy in maybe around 4 or 5 billion years. That's billion like starting with a B like Bravo. So I don't know if any of us will feel that collision, but boy, if we do, it is not going to be fun, is it? Basically what will happen is we will merge and sort of form up a giant elliptical galaxy. Or, depending on the way the merger goes, you know how mergers are, sometimes they're pleasant, sometimes not. We might be a large lenticular galaxy. This galaxy has an apparent magnitude of 3, literally, 3.4. So that's why you can see it as a naked eye object. And if we could see through this cloud bank, by the way, remember, this live SkyCam view travels with the RASA. So you can see it mounted in the left frame of this view. You can see it's riding on top of the RASA. So whatever the RASA looks at, this SkyCam looks at. So you're viewing now the Andromeda Galaxy down there on the horizon. Anyway, if we could see it, it would be magnitude 3.4 right now, and it would be the brightest Messier object in the whole list. So everything we look at from here on is going to be fainter and fainter. This is visible to the naked eye, especially on a moonless night. And even if you're in a spot with some light pollution, you could still see this Andromeda Galaxy. So it's pretty cool. Stu says, yeah, that merger is going to be like a hostile takeover. Tiffany says she'll be in heaven watching that collision. So I'm with you, Tiffany. If the Lord lets us use binoculars from heaven, let's hope we can watch that. Gerard thinks that the Lord will have returned before 3.5 or 4 billion years. So I think you're probably right, Gerard. But if not, either way, like Tiffany says, maybe we can watch this from heaven. Well, the next target we would have seen, same frame, is this satellite, Messier 32. And this Messier 32, as you can see, kind of just appears to us like it's a blob. And some might call this a dwarf galaxy, maybe a dwarf early type galaxy. And this is discovered by Guillaume Le Gentil in 1749. It's more like an ordinary elliptical, and it does contain some faint red and yellow stars, but practically no dust and or gas, which you can imagine why, because this giant neighbor here ate it all up. So no star formation, kind of a dead dwarf. Then the third object here in this frame we would have looked at is M110. M110 is a little better. You can see it has a little bit more going on. It's another dwarf elliptical, and Messier didn't include this in his catalog. However, he did observe it, and he made notes of it in his journal. So what happened was, later on, Caroline Herschel actually officially discovered it and described it, but then there was a guy named Kenneth Glenn Jones who studied Messier's notes and found it, and thereby could say, although we don't know the exact night that Messier observed it, since it was in his notes and he would have preceded Caroline, then we know that it would have been Messier that should have been credited with the discovery. And it's even in his drawing that he made. It's called Nébuleuse d'Andromède, or whatever that is in French. And he labeled it even. And that was in 1773. He labeled it. So that's why Kenneth Glenn Jones was able in 1967 to get the astronomical community to add it. Remember, Messier had what? 105 objects, was it? Or 104 maybe, depending on how you count a couple of missing ones. So this Kenneth Jones was able to sell the community on adding this to the list. Well, this object is not slated to set at our horizon here until 10:04, but you can see it looks to me like, if our calculated horizon is correct, it would be very close to contacting that horizon. Gerard says these deep sky objects are much closer than Carl Sagan, and all those intellects have led us to believe. Maybe, Gerard. And yes, Gerard's making note of the fact that if you use the genealogies and the dating system of trying to make sense out of the years in the Bible, that the whole of Earth's creation would be just a few thousand years old, 6,000 to 7,000, Gerard says. I just want to say that I think, here's my own personal theory on that, and of course, I don't mean to try to either convince you or not. It doesn't really matter to me which direction you want to believe, but one explanation is you could argue that maybe the Bible's not necessarily a clock. It never presents itself as a clock. For instance, we know that some of those Jewish genealogies that Hebrew scholars use to try to date the things in the Old Testament, including creation, we know that Jews were famous for including famous people in their genealogy if they were a cousin. And we know, because we see it at times when Jewish scholars would leave out infamous people who were horse thieves, even though they were a grandfather, they would leave them out of the genealogy. So on the one hand, I think it strengthens the argument that the Bible's not a clock. But then on the other hand, if you make a model of something out of clay, you finish the clay pot. You could say, now how old is that clay pot? And you might make the case with your grandson that it's 5 minutes old because you just formed it. But if an archaeologist visits you a little bit later, if the archaeologist bases the date on the source material, the clay, in other words, it's hard to know what the date of that object is because the clay is much older. And my point is that when God created the heavens and the earth, when he created the universe, and I believe he did, he created it as a television program already in progress. So you tune in to your football game late because the president gave a speech, and man, they're already in the second quarter. That's because they were playing the game in progress while the president spoke. So in similar fashion, I believe when God made the Andromeda Galaxy, he didn't suddenly make it that day when he created it, if he created it in a day. He didn't make it as if it were just starting because it would take a long time to form. He gave it an apparent age when he willed it into life. So I think the apparent age, as we look at it, could literally be whatever number of million years that astronomers are saying, because maybe he created it, do I have the age written down for this? I forget. I guess I had the age for Andromeda Galaxy, didn't I? 4 to 5 billion years. So when he created it, he could have created it as a galaxy that was already 4.5 billion years old. And then we're observing it 6,000 years after he created it to look like it was 4.5 billion years old. That would be easy for God to do because he can create it like the football game, already in progress. He can create it in motion. So I don't think the Bible's a clock, but I also think he could have created the universe in motion. So there you go. All right, the next object we would have gone to would have been M79. So let's go there now. M79. So there you see the scope starting to move. It's the most exciting thing happening in the sky tonight. Stu points out some people thought the Earth was flat. Tiffany likes the explanation of the Bible's not a clock and the Lord could have created the universe to look like it was 4.5 billion years old. Gerard has a hard time getting his arms around saying that a certain object is billions of light years away and trying to understand all that. That is, those distances are crazy. And Stu says, well, because we don't understand it, it doesn't mean it's any less real. Walter says it's a clock in reference to prophecy. Yeah, if we knew for sure, exactly, Walter, if we knew for sure when the prophecy happened, but unfortunately we don't have any kind of way to figure out the sequence of things and how far apart they are, because of the fact that Jews didn't look at genealogies as clocks. They would leave out certain generations if it didn't fit their poetry or their notion. If they weren't proud of those people. We know this because we can see different examples of the same sets of genealogies with people left out, and that's not a glitch in the Bible or Josephus or anybody else. It's just a trait of Jewish genealogy tracking. It's just the way they did it. It's just part of their culture. So anyway, now to line up NGC 1904, we just click up here and say Stellarium sync, and bam, there we are. So to get a sense of where we are, there is my truck parked over here in front of the observatory when I took this picture. There you can still see the tree line, and now we're looking at west-south. I mean, we're looking at south-southwest, just a little bit south of southwest. And this object is N79. It is a globular cluster, so our first globular cluster of the night. And this is in the southern constellation of Lepus. If we were able to see it right now in that sky, it would be at roughly 16 degrees above the horizon. And our sky in this part of the horizon is really good. There's a little town down there, so that's a little problem. It's a town called Bardstown, I guess. And we can pick up a little bit of the light pollution from Bardstown, just a hair. And a little bit of the light pollution from the southern part of the skyline of Louisville. But the tree line is almost exactly at like 1 degree. So it's a great sky down there. We're able to observe things really low to the horizon on a clear night. This globular is in Lepus, and it was also discovered by Pierre Messier, Messier's assistant. And it's about 42,000 light years apparent distance away from Earth, and it's about 60,000 light years from the center of the galaxy. And we believe that this particular globular cluster is not native to the Milky Way. And what happened was it was sort of captured through one of those close encounters that objects have sometimes out in outer space. We'll see later on, hopefully live by that time, M51, the Whirlpool Galaxy, where two galaxies have captured each other and they're now in a dance, a kind of a dance with each other. And this is just a theory, of course, and astronomers still debate it, but it's either a part of a captured galaxy, but it also might be a part of a larger tapestry of deep sky objects in our part of the world. And that tapestry has a funny name. It's called the Gaia Sausage. And it's a cluster of lots of deep sky objects, just like this one, Messier 79. But either way, this particular globular cluster is being disrupted by something. And you can see how these stars are starting to pull apart from it. So I don't know what you call that. It looks kind of like, if you could imagine it as coming up to land on us, it's some kind of an insect, isn't it, with multiple legs, or maybe a horse whose legs have gone out from underneath him. I don't know what kind of image you see there, but this is M79, otherwise known as NGC 1904, and we would have a beautiful view of it if it weren't for all those clouds. And we've missed now our 7th object in a row, so no matter what, we cannot score more than 103 tonight, can we? Let's go to the Scorpion. Now this object is circumpolar, so what that means is it never sets. So we could come back to this one. I don't know if we have a picture of the moon in that Skycam, Gerard. That's probably Bardstown shining through down there. It is amazing that we can see these objects, Gerard. You're right. And you're right, this is an incredible region of the night sky with all those clusters, Leo and Virgo. Stu feels like that this should be a squash spider hit with a magazine. So that's the spider swatted with a magazine, according to Stu. Gerard says we're on a roll now. We're wiping these objects out. I guess my point is, since this next object is a circumpolar object, if the sky's clear, we could actually come back to it. But let's go to it anyway, just so we can say we've been there. Is it my imagination, or do those clouds look a little thinner overhead? Aren't those a little bit thinner behind the scope there? You might be wondering how we come up with this order, because you can already tell we're not doing this in order, Messier 1 through 110. And that's because Charles Messier didn't do them in order. He did them in the order that he wrote them down. And that's it. It was the order that he wrote them down. So if he found one, then that was the next sequential item in his list. If Pierre Méchain told him about an object, that would be the next one in the list. So what we do when we're going to do a marathon is we calculate the most efficient order that we could use to view these objects. And typically the most efficient order, at least at the beginning of the night, is to grab the ones that are about to set. So they're sinking into the west. You want to do those first because your time is limited on those. So let's go and find M52, even though it's
selected,
not going to set, but we'll go and find it because in the sequence that we had, it was at least the next object that we could go to right now. So now you see we're in the northern region. That's why I say by circumpolar it means it's got to be within, 30 degrees of the North Star. So right here is the North Star, and there beside it would be the North Celestial Pole. So as you can see, the North Star is not precisely lined up with the North Celestial Pole. And most of the time when you're out hiking, that doesn't matter because you're not down to like 1.5 degrees. But in astronomy, it matters. We don't align the telescope. You see how it's aligned here, and it's directly pointing at the celestial pole. We don't align this Rasa with Polaris. We instead align it with the true celestial pole, which is off to the right of Polaris a little bit. See right here, you can see right now. Well, anyway, down here, low and to the left, so a little bit west of north, you can see this next object, which is M52. And some people call it the Cassiopeia. There goes a satellite by the way, that's trailing across the sky in Stellarium. Some people call it the Cassiopeia salt and pepper cluster. Others call it the scorpion, which sounds much more terrifying. Yikes. So there must be some kind of a tail here. If we could make it out, there must be a scorpion's tail. This open cluster was discovered by Messier himself, and it was discovered in 1774. Now we know that some of it is being obscured by at least dust, if not dark matter. We really don't know what dark matter is, but in the southern half here, you can see quite a bit of blotchiness. And using a bunch of different means, including infrared and radio telescopes and pure calculations, we now know that some of this is being obscured by that dust and dark matter. So visually, these just look like holes in the cluster. But now we know they're not really holes. They're being covered up by stuff, ashes and carbon and dust, stuff that's between us and the salt and pepper cluster. M52. Oh, Dave. Dave was just able to capture M74 before it set. Well done. So now, Dave, can you go grab M77? Gerard, Orion comes up a little bit later. It's about, I don't know, 13th in the sequence. So it's not very much farther, about 5 objects from now. Ray, good to have you aboard. Yes, we're so much better off. I'm going to sneeze. I wonder if I can mute before I sneeze. There, I talked about it, so maybe I've talked myself out of it. Yeah, Ray, we're so much better off than you. I'm so glad that we are not as clouded out as you. No, I'm just joshing, Ray. We have every bit as many clouds. If you've tuned in late, it's 10:15 Eastern Time, real time, and we had thought that the clouds would clear about an hour and a half ago. But what do you say we go now to the little app, and once I find the right screen, we'll go to, oh, I've already got it open here. Anyway, here we are, and I'll just refresh just to make sure we have the freshest view of that. Oh boy, look. They keep stretching this later and later. Originally, it was to have cleared at 8:45. And then it said 9. You know, that didn't happen. Now you can see they've got it at 74% cloud cover at 10 and 54% cloud cover at 11. And a third cloud cover at midnight. Boy, gang. If we do not get clarity by midnight, then I wonder if we should reschedule again. Ray says he's glad so he can see the sky. Thankfully, you are clear. But see, that's just it, Ray. The big secret is we're not. It's very cloudy here. There's the sky cam. And then if you want to see what the scope is seeing, there is our view through the ZWO-ASI 2600. Let's put this on 3 seconds now. Nothing but a little bit of light pollution being caught by the clouds. So that's our live view. We're in exactly the same shape as you, Ray. Gerard says, yes, let's reschedule. Larry says, yes, let's reschedule, but hard on you to keep doing this. Not really, Larry, because I would have gladly come for a 2-hour observing session. And typically we've been starting those at 10:30. So, but I do think it's going to make the most sense to reschedule. The other thing we did do is we were able to test and demo the Stellarium control panel that our good friend Pete, and he was observing with us a while ago. I'm not sure if he went on to bed, but Pete is working on this. Watch. You saw the way it lines things up in Stellarium.
Selected.
And now you can also see the way it will capture.
DSA completed.
It will capture the exact settings needed in SharpCap. That if we could go over here and turn on the deep sky image annotation and have it make any sense. But see, I don't think it's going to work because I think it would require plate solving. See, no plate solving information available. So it can't work without plate solving, but it captures information from the AstroPlanner line item. So if you're looking at a new, comet or asteroid or whatever you found, then you can come over to SharpCap and it places crosshairs on the object. So thanks, Pete, for making those. And then if you're in Stellarium and you find a new target and you place it here in Stellarium, then you can copy it into AstroPlanner. So it goes the other way as well. So remember a while ago we went over and saw the comet Pons-Brooks. We could click on that and then use this selection, which is called Add to AP, and it adds the coordinates from Stellarium back into AstroPlanner in one click. So that's pretty slick. And you also can use it to do an observation. I won't do that because I could do a fake one here real quick just to show you what it does. So it gives us this panel, testing 1, 2, 3, and then I'll remember to remove this. So
observation logged.
I'll remember to remove this so it doesn't look like we're faking it. Let me go do that right now so I don't make it look like we're trying to cheat. So here it logged this observation of M52. Now I'm going to erase that. And that way it'll remove this observing session again. But that's how quick it is. You don't have to wait for all that redrawing of the screen. And he reads all this in at first, and using this control panel, and you don't have to wait for one script to load in over the top of the other, like you saw last time if you watched the last video. So it's really a cool panel. And yes, you can use Stellarium to control the mount as well, but that defeats the purpose of your list that you have in AstroPlanner, of course. Let's check the sky one more time. Boy, it's eventually going to clear it up. I think we'll go until maybe 10:30. Let's go for another 10 minutes or so. Let's do one more object, M103, and we would slew that to M103, otherwise known as NGC 581, because this will let us see another open cluster, and it's a faint cluster. It's discovered in 1781. Again, we'll sync up to it here in Stellarium. All we have to do is click that button, Stellarium Sync.
Selected.
And it just immediately puts it right in our frame of view, doesn't it? I love this. So again, that's back to north-northwest. And it's got a nice few brighter stars, doesn't it? But most of them are faint. and has about 40 stars that are certain. A couple of these brighter stars are foreground objects, actually. It's like Struve 131. I believe that might be. One of these. These are foreground stars. If you go all the way down to the faintest star that's detectable, I think we can see about 172 in this cluster. And might be 22 million or so years old in apparent time. Nice red star here that would be beautiful if we could see it through that sky. Again, you can see some holes in the sky where the clouds are just starting to part. Ray says there's rain in the forecast out in Colorado. Gerard says that it can be pretty miserable in Michigan, the Great Lakes. Larry says post a link. I think we have most of this written in the description already, Larry. But the new panel that I'm demoing tonight is still being worked on. This is a beta version that Pete is just allowing us to try out. When he finishes this, he will post it as an add-on script in the AstroPlanner script, in the AstroPlanner forum. So you'll be able to download it. And I've suggested to him he might want to charge for this, and he refuses because he's that kind of guy. He's just an incredibly kind guy, and he's going to give this away for free after all the hours he's investing in it, just to be good back to the hobby. So you'll be able to find it on the AstroPlanner forum for free. Mike is going to come back whenever we reschedule. It's awesome, Mike. It's good to have you back here. Gerard says this is a very friendly community, and he says that makes observing fun again. It's not tense or like we're competing. So you're right, Gerard. He says, oh, I'm doing a good job, but it's also the community here does a good job. It's really incredible. Pete and I were talking about this via email, and he said, yeah, the people are so social. They're so friendly. And Larry, that's what I meant about the panel. That panel is going to be for free on the AstroPlanner forum, because the panel is meant to work with AstroPlanner. That EAA CP, electronically assisted astronomy control panel, it does not right now exist apart from AstroPlanner. It lives in a script inside of AstroPlanner's script engine. So it would only work if you were running AstroPlanner with it. And that's why Pete's going to post it there in the forum. And it is going to be drop dead simple to install. You don't have to do any weird executables or download anything apart from just grab the script off of Paul's forum there for AstroPlanner and use a simple copy and paste that Pete will show you. Tiffany says, yeah, we're a good bunch. That's awesome. Well, so why don't we go ahead and wrap it up for tonight? It's 10:30ish, and I'm so sorry that you can see the sky is thinning. The clouds are thinning, but still not enough to make out even one target. I think by midnight or so, they'll be clear, but for the purposes of a marathon, you know, you want to start and catch M74 and M77. Stu says, and Doug is the sweetest. Stu, you're a rascal. I think we want to catch M74 and M77 if we can, because we know already from the place where the observatory is located, we know for sure that we will not get M30 because of the way the building is in the way. I think that's best viewable if we go to let's do this. Let's do one more thing before we go. Let's run the clock forward. And I'm watching the time here. So now we're speeding up the sky. So there is midnight. There's 1 a.m. 2, 3, 4, 5, 6. Okay, I'm going to pause it just for a second because I'm going to go down and look and see what time does M30 rise. M30 rises at 8:24 a.m. So now let's go back to the, and I got that rise from AstroPlanner. So 8:24. So let's go, see, we're at 6 right now. So let's go to 7, 8. Okay, that's 8:16. Let's just go to 8:24. Okay, so this is tomorrow morning, and now I'm going to sync with M30.
Selected.
Now it's showing M30 there at 8:24. Well, you got to keep in mind, looking up here at the top of AstroPlanner, the sun rises at 7:46. So 45 minutes after sunrise, it doesn't matter. I think 8:24 is the compensated time that M30 rises over the top of our building. You see how these trees and the building are here? So what I've got AstroPlanner set to do is I've got it set to show the time when it's first visible over the top of the building. And, you know, I don't have my photorealistic horizon or this horizon here set very accurately, do I? But it's going to be so low in the sky at sunrise that we're not going to see the jellyfish cluster anyway. So we know we're already going to miss M30. So 109 is the best we could do. But you wish that we could get a clear night from, say, 8 p.m. until 8 a.m., right? So we can catch as many objects as we can besides M30, at least with 109. How about that? Stu says, well, we've done the first half of the marathon. That's right. The other night, when we did the first 60 objects, we captured 60. You're right. Stu says, well, you know, in running a track, you know, in running they count a half marathon. That's almost as good. That's a good way to look at it. Gerard says, well, astronomers have to be diligent and patient anyway. Stu said, I just poured a hot cup of astronomer steroids. We can't stop now. Gerard says, well, we have to start with a good beginning. Tough to miss out on some of those early ones. And Pete says, thanks, Doug. A really enjoyable session, even with the clouds. It's great to be here with all these amazing people. And you stayed up late. Man, I'm thinking it's probably 2:30 a.m. there, Pete. You are the one who gets the prize for staying up the latest of all. Thank you. And boy, say goodnight to the Isle of Wight for us. And we'll go ahead and say goodnight as a group. We'll come back. Again, we'll be watching for the first clear night. I want to make sure you guys understand, I watch this thing like, I'll use the word religiously because I'm almost, look up on my bar here, it's the first link on my shortcuts bar. And you can see why tonight I thought it would be clear. Now see, tomorrow night is looking clear, but I have to be at a conference tomorrow night, so that's a problem. And the moon's just getting brighter and brighter, 78%. So I'll keep watching this, and once we get back into something clear again, and I'm here at the observatory, we'll let you know again with at least 24 hours, if not 48 hours notice, and I hope some of you can make it back. Well, God bless you for being here. Yet another practice session. Lets us develop this kind of expectations, muscle memory, And using this particular control panel, we didn't have this done yet. Pete had not finished this yet. So we're farther along, and he keeps working on it. So probably next time it'll be even better. But no pressure, Pete. It's already perfect enough. So God bless you guys. Tiffany, you're so kind. She says she's going to be here. She's going to follow no matter what. Good night, all. Kevin, good night. Ray, good night. Good night to all of you folks that are out there. Thanks for tuning in. If you like this kind of content, it would be awesome if you would consider hitting that thumbs up or the subscribe or the bell, because that way you'll be notified through YouTube when we're going to do this kind of astronomy. We love it because you're doing astronomy with us. We're discovering this stuff as we go, and we'll look forward to seeing you next time. That's it. Talk to you soon. God bless, and thanks to God for making these cool clouds, which we love. They clean the air once they rain on us. Take care. Good night. God bless.